All right. Number 4. Find the key features of f of x equals x squared minus 4x plus 8 and then graph. So first things first, I'm going to start by identifying my a, b, and c. I'm in standard form, so I need to identify those. A is 1, that's in front of x squared. B is negative 4, because that's what's in front of x. And c is the number without a variable, which is 8. All right, I also know that this is going to open upward because the a value is positive. All right, so when the number in the front is positive, it's going to open up. All right, so I'm going to find my axis of symmetry first. Remember, that's x equals, and then negative, and then plug in your b, which is negative 4. So that's going to be positive 4 over 2 times a, which is 1. So we get 4 divided by 2, which would be 2. So our axis of symmetry is x equals 2. Now I'm going to go ahead and plot that on my graph. All right, so I'm going to go to 2. Always pay attention to how you're being, how your graph is counting. So I'm going to go to x equals 2, and I'm going to put my dotted line. It has to be dotted because it's not really a line on the graph. It's kind of like a guideline. All right, then I'm going to find my vertex. Well, I know that my vertex is going to have an x value of 2 because it always matches my axis of symmetry. That's because it goes straight through the vertex. So to get my y value, I'm going to take that equation that I was given and plug in 2. So I have 2 to the second power minus 4 times 2 plus 8. So I have 4 minus 8 plus 8, which gives me a y value of 4. So my vertex is going to be at the point 2, 4. So I'm going to put my vertex 2, 1, 2, 3, 4 on there. Now remember, the dotted line just shows this is a guideline. Your vertex should always be on that line, all right, because they share an x value. Now, there's a couple of other things I can tell from this graph, and I'm going to show you 2 ways to do this. So if I wanted my y-intercept, I could plug 0 in for this x, that would go away, and 0 in for this x, that would go away, and then I could find out that my y-intercept is 8. Now, sometimes that is helpful, and sometimes it is not. I'm going to plot the y-intercept on here right now, and then I'm going to show you something else. You need to have 5 points, okay? At least me as a teacher, that's always what I want for my students is 5 points. All right, 5 points on the graph. So I have 2 right now. I need 3 more points. Well, 2 of those are going to come from mirroring across my axis of symmetry. But let's say that I didn't have the y-intercept. I would need to get 2 more points on this maybe left side. So if my axis of symmetry is sitting at 2, I want you to pick x values that are either 1 and 2 to the left or 1 and 2 to the right. So when I plug in x values, I'm going to choose an x value of 1 and an x value of 0. Or I could choose an x value of 3 and an x value of 4. All right, that is totally up to you, but I always do the 2 x values that are directly to the left of my axis of symmetry or directly to the right. Because the farther I get away, the higher or lower those points are going to be, and sometimes they don't fit on the graph. So I'm going to choose 1 and 0. Those are the 2 that directly to the left. So let me take off these arrows I've put on here. So to get the y values when x is 1, I'm going to plug 1 in just like I did when I plugged 2 in for the vertex. So I have 1 squared minus 4 times 1 plus 8. Again, I just took that equation I was given and plugged in 1. So when I plug in 1, I get 5 as an outcome. 1 squared minus 4 times 1 plus 8 is 5. Okay, and I'm going to go ahead and do 0 as well. Now, we already know the point there, but sometimes I have students who don't really want to use the y-intercept because it's not always useful. If it was at 32, it wouldn't be even fit on my graph, so it wouldn't be useful. So I have some people who just prefer not to use that. So if I plug in 0, 0 squared minus 4 times 0 plus 8 is going to give me 8. So I'm going to plot those points, 1, 5, and I already have that point there at 0, 8. Now I have 3 points now. What I'm going to take is, I'm going to take this point and I'm going to mirror it across this axis of symmetry. So if I have a point that's 1 left, I now have a point that is 1 to the right. This point is 1, 2 to the left, so I'm going to put a point 1, 2 to the right. Okay, and then I can draw in. Make sure you hit all those points. And this is going to continue up and out. So I have my graph there. 5 points. Okay, so number 5. Again, using the key features, I'm going to graph. So I'm going to start by choosing A, B, and C. A is 1. B is -6, and C is -1. I know that because A is positive, it's going to open up. So it'll look something like this. I'm going to start with my axis of symmetry. So I know that that's x equals negative, negative b. So negative, -6. That's a positive 6 over 2 times 1. So 6 divided by 2 is 3. So my axis of symmetry is at x equals 3. So I'm going to go ahead and put my dotted line at x equals 3. All right. Then I'm going to find my vertex by plugging in that x value of 3 into the equation that I am given. So I have 3 squared minus 6 times 3 minus 1, which gives me -10. So my vertex is at 3, -10. Remember, that should always be on your axis of symmetry. Now this time I could plot my y-intercept at -1. That would be useful. But in this case, I'm going to go ahead and just choose 2 x values to get some extra points on my graph. So I only have 1 I need to plug in, so I get 2 points, and then I can mirror those across the axis of symmetry. So since my axis of symmetry is at 3, I'm either going to choose an x value of -2, or not -2, 2 and 1, or 4 and 5. Always choose on the same side because you don't want to have to do work that's just going to mirror onto itself. So 2 to the left or the 2 to the right. I'm going to go with the smaller numbers, which is 1 and 2. So I'm going to plug 1 in, and I'm going to plug 2 in just like I did with my vertex. So I have 1 squared minus 6 times 1 minus 1. That's going to give me a y value of -6. I'm going to do the same thing with 2. 2 squared minus 6 times 2 minus 1. That's going to give me a y value of -9. So I'm going to go plot these. Let me erase these extra little dots I put on here. So 1, -6, and 2, -9. So now I'm going to take those points and flip them over my axis of symmetry. So I have the point 1, -6. So I've flipped that over. That's going to be another point that's 2 to the right. And then I had a point 1 to the left of my axis of symmetry. So now I have a point 1 to the right. I have my 5 points. I'm going to draw this in, make sure it's not pointy, and put arrows on the end to signify that it's going to continue going up and out. All right, the graph of this function right here shows the profit a company earns for selling headphones at different prices. What is the maximum profit the company can expect to earn? So down here, we know that the X is going to be your selling price. All right. And then your Y value is going to be your profit. These are all in dollars. So they want to know what the maximum profit the company can expect to earn. Well, Y is my profit. So it's whatever is way up here. Well, it looks to me like that might be, looks like I'm counting by 250s here. So I'm thinking that's 6250, okay? But I want to be, completely sure. So I'm going to find my vertex. That's what this spot is. That is my vertex. And they gave me the equation, so I don't have to guess at what that point is. I'm going to find the axis of symmetry first. So x equals the opposite of b. Well, b is the number in front of x. So 700. And remember, it's negative b. Well, in this case, this is our first one where b has been positive. So we have a negative 700 all over 2 times a. In this case, a is negative 10. So negative 700 divided by negative 20 would give us 35. So I know that the selling price is going to be $35. That gives me the maximum profit. But remember, I want the maximum profit. So I'm going to have to take that 35 and plug it in to get the Y value of that vertex. So, it's not negative. So I'm going to plug in 35, so negative 10 times 35 squared plus 700 times 35 minus 6,000, and that's going to give me 6,250. So that is the Y value, which is my maximum profit. That's the most that they are going to make from selling these headphones. A water balloon is tossed straight up from the ground. The weight of the water balloon over time can be modeled by the function y equals negative 14x squared plus 34x plus 3. What is the maximum height of the water balloon? So if I toss a water balloon, it's going to make some kind of upside down U shape. And the maximum height would be this spot right here, which is my vertex. All right, so I need to know the maximum height. That's the Y value of the vertex. To get the Y value of the vertex, I need the X value of the vertex. So I'm going to find the axis of symmetry. So X equals negative B. Well, in this case, B is 34. It's right there in front of the X. So 34. All over 2 times A. A in this case is negative 14. So I have negative 34 over 2 times negative 14. That's going to give me 17 over 14. So it's not pretty, but it doesn't matter. All right, so we have 17 over 14. So now we're going to plug that into our equation to get that Y value. So we have negative 14 times 17 over 14 squared plus 34 times 17 over 14 plus 3. That's going to give me that Y value of 23.6 feet. So that is the highest that this is going to go. All right, number 8. Esteban is training for the discus throw. His coach recorded the horizontal distance and height of one of Esteban's discus throws. The graph shows the horizontal distance the discus traveled in meters and the height of the discus in meters. What will be the height of the discus when it has traveled 15 meters from Esteban, and then validate your model? All right, so we can see that this graph is kind of going up, 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 and eventually the discus is at some point going to start coming back down. So I have to write an equation for this, and we are going to use our calculators to do what we call a quadratic regression. That means we're going to give it some data, and it's going to give us an equation that's going to go with this set of data. So all of these x values, I have a 1, a 2, a 3, a 4, so on and so forth. And then all my y values, the 1.75, 2.71, 3.52, we're going to put those into the calculator. Now, there's something that we want to turn on. So grab our calculator here. We're going to go and make sure that your regression is on, okay, or not regression, my diagnostics. My diagnostics are already on, so if you go to second and zero will bring up the catalog, and you're going to go all the way down until you get to diagnostics on, and you're going to press enter and then press enter again. All right. All right. For now, though, once you get that done, you're going to go to stat, and then we're going to click on edit. All right. Now, you may have numbers in here. I do. You may not. Okay, but mine has numbers in list 1 and list 2. So I want to clear those out. So if you hop up to the list title and press clear, and then when you drop back down, those numbers are going to disappear. Do not press delete. All right, so go through and you're going to put in all of your X values into the list 1. So we have 1, enter, 2, enter, 3, enter. So just keep putting your number in, and we're going to go all the way up to 10. Make sure you press enter after 10. That way it stays in your list. Then you're just going to push the over arrow, and then you're going to put in all the Y values in the same order. So we have 1.75, enter, 2.71, enter, 3.52, enter. So just keep going down through that list and put those numbers in. All right, so your list 1 should match up with your list 2. Okay, and then you want to make sure that you've put those in correctly. So recheck over your data, because if you have one thing wrong, it's going to mess up everything. Okay. All right, now we've put our data in. We've given the calculator the points. Now we're going to go back to stat. And this time, instead of editing something, we want to do a calculation. So we're going to arrow over to calculation. Now, as you can see, there are different types of regressions. We have number 4 is a linear, number 5 is quadratic, 6 is cubic, 7 is quartic, so on and so forth. So we are doing quadratics. So we're going to do a quadratic regression. So we're going to choose option 5. And then this is just verifying that everything is where it should be. So our X's, they are in list 1. All right. Our Y's, they are in list 2. So we're going to go down to calculate and press enter. Now, as you can see, they've given us standard form there at the top, y equals ax squared plus bx plus c. And then they gave you the a, the b, and the c. This R2 value down here, that is telling you how good of a fit it is to a quadratic equation. The closer it is the 1, the better fit it is. So I look and I see I have 0.998. That's really close to 1, so this is a really good fit. So we're going to give this 3 decimal places for A, B, and C. So I'm just going to take this A and I'm going to plug that in for A. I'm going to take the B and plug that in for B. I'm going to take the C and plug that in for C. So that gives me y equals, the a value was negative 0.027 x squared. The b was 1.058, so plus 1.058 x. And then c was 0.672, so plus 0.672. And there you have that. Now remember that R2 value there was really close to 1. So that means this is a good fit. Okay? So then it says, what will be the height of the discus when it has traveled 15 meters from Esteban? Well, the distance here, that's your x value. So it's saying when it's traveled 15 meters. Well, if I want to know how high it gets, I just need to plug 15 in for the x's. So I have y equals negative 0.027 times 15 squared plus 1.058 times 15 plus 0.672. I'm going to plug that in my calculator, and it's going to give me 10.5 meters high. And again, that would be what happens when it's 15 meters away. It's going to reach a height of 10.5 meters. All right, number 9. A fan threw a souvenir football into the air from the top of the bleachers towards the bottom of the bleachers. The table shows the height of the football in feet above the ground at various times in seconds. If the football was not touched by anyone on its way to the ground, about how long did it take the football to reach the ground after it was thrown? Okay, so they gave me some data again. I don't know the equation to this. I don't know what the vertex is, but I'm going to use my calculator. And I'm going to do time as the x, and I'm going to do height as the y. So go to your calculator. We're going to go back to stat and choose edit and take the data out we previously had. So jump up to that list, press clear, pop back down, and then go over and clear the other list. So you're going to put all of those x values, the times, in. So you have 0, enter, 0.2, enter, 0.4, enter, 0.6, enter, 0.8, enter, 1, enter. All right, pop over and put all of the y's, which is your height, 10, enter, 11.76, enter, 12.24, enter, 11.44, enter, 9.36, enter, 6, enter. All right, then we're going to go back to stat, over to calculate, and we're doing a quadratic regression again. So 5. Again, x's are in list 1, y's are in list 2, so go to calculate and press enter. All right, this is a perfect fit. Look at that R2 value. It's a 1, so this is perfect. A is negative 16, B is 12, and C is 10. So we have y equals A is negative 16, x squared, plus B is 12, so 12x, plus C is 10. Now it wants to know when it hits the ground, so think about this. They throw it when no time has passed, and then eventually it hits the ground right here, somewhere way over here. That is your x-intercept. That means that you need to plug 0 in for y. Well, if you're good at factoring, then you could factor this and do that, but we haven't talked about factoring in my class so far. So we are going to go ahead and use our calculator to help us with that. So back on the calculator, I want you to go to the y equals. If there's something in there, press clear. I also have a plot on, so I'm going to go up and press enter and take that off. And we're going to put in that equation, negative 16x squared plus 12x plus 10. And I'm going to go to my graph. Now my graph is all wonky and it's not in the center, so if you want to get back to the center, we're going to press zoom and 6. Okay, and I see right here that we have an x-intercept here and an x-intercept right there. Okay, now obviously we can't have a negative amount of time that has passed, so this x-intercept doesn't matter. It's only this one that we're looking at, and it looks like it takes over 1 second, but I want to be for sure. So I'm going to go to my calculate menu, which is second and trace, and I want to find the 0 right there. Okay, and x-intercept is also called a 0 of the function. All right, so we're going to click on 2, and then it's going to give me some things. Well, I want to get a little closer, so I'm going to arrow to the right until I see that little guy. So when he's to the left of my x-intercept, I'm going to press enter, and then it says, are you right bound? So I'm going to keep arrowing him over until he's on the right side of my x-intercept, which he is now. So I'm going to press enter and then press enter again. And it tells me that when y is 0, x is 1.25. So it took him 1.25, took the ball 1.25 seconds to hit the ground. So 1.25 seconds. All right, number 10. We're supposed to identify the axis of symmetry, the vertex, the direction of opening, the minimum or maximum, and then graph it. All right, so let's start with our A value. A is 2, B is 16, and C is 33. I'm going to find my the way it opens. So A is positive, so this is going to open up. All right, and I'm going to find my axis of symmetry, which is x equals negative b. So that would be negative 16 over 2 times a, which is also 2. So x equals negative 16 divided by 4, which would give me negative 4. To find that vertex, I'm going to plug in the negative 4 into that equation that they gave me. So I have 2 times negative 4 squared plus 16 times negative 4 plus 33. That's going to give me a y value of 1 for my vertex. So I'm going to go ahead and plot my axis of symmetry, which is x equals negative 4, and my vertex, which is negative 4, 1. Now I need 2 more points. Now if you look, this is your y-intercept. That's not going to be helpful because this graph is only going up to 10. So we're going to go ahead and pick 2 numbers to the left or to the right of my axis of symmetry. So I could do negative 3 and negative 2, or I could do negative 5, negative 6. I'm going to do negative 3 and negative 2. Again, that's just to the right or left of that x value of your vertex, also known as the axis of symmetry. So when I plug in negative 3, I have 2 times negative 3 squared plus 16 times negative 3 plus 33, which gives me 3. I'm going to do the same thing for negative 2. So 2 times negative 2 squared plus 16 times negative 2 plus 33, and that gives me a y value of 9. So when I plot those, I have negative 3, 3. Oh, I went the opposite direction. Negative 3, 3. And negative 2, 9. Now to get those other points, remember I'm going to mirror, so I'm 1 to the right, which on this graph is actually 2 little tick marks, so 2 tick marks to the left. This one up here is 4 tick marks to the right, so I'm going to go 4 tick marks to the left, and then I have my 5 points. I'm going to make sure this isn't pointy. It helps if you like curve a little before you get there. Arrows on both ends. All right, it also told us to identify the minimum or maximum. This one obviously has a minimum at, and then that low point right there, which is 1. All right, number 11, the A value is negative 1, B value is 6, and your C value is negative 13. This is going to open down because A is negative. All right. And now let's find our axis of symmetry. So the axis of symmetry is x equals negative b, b is 6, all over 2 times negative 1. So x is equal to negative 6 divided by negative 2, which gives me a positive 3. So to find my vertex, I'm going to plug that x value of 3 in. So I have negative 3 squared plus 6 times 3 minus 13, and that gives me a y value for my vertex of negative 4. So I'm going to go ahead and go to 3, plot my axis of symmetry, write down that middle of the vertex, which is at 3, -4. And then I'm going to choose a couple of x values. Now remember, you want to go, since we're at 3, you could do 2 and 1, or you can do 4 and 5. Just the 2 to the left or the 2 to the right. I'm going to do 2 and 1. So I have negative, plug in 2, 2 squared, plus 6 times 2, minus 13. That gives me -5. So when x is 2, y is -5. And then I'm going to do the same thing with 1. So I have negative and then 1 squared plus 6 times 1 minus 13, which gives me a y value of -8 when x is 1. So 2, -5, and 1, -8. And then you're going to mirror those. So the top point is 2 tick marks left. So we're going to go 2 tick marks right, 4 tick marks left, and 4 tick marks right. And then draw your graph in. And then you have a maximum this time at, and then name that y value -4.